Hello, everyone. In this video, we are going to look at setting up and simplifying the difference quotient with the function f of x equals square root of x minus 1. So first thing we want to do is compute f of x plus h so that we have the general form of the terms that we need for the difference quotient. So f of x plus h, that means we're going to plug in x plus h everywhere that we previously saw x in our function rule. So that looks like for us, square root of x plus h minus 1. So take a moment and pause the video and set up that difference quotient on your own, and then we'll look at it together. All right, so let's compare our work. So that difference quotient, we're going to start with f of x plus h. So we're going to say square root of x plus h minus 1. Then we're going to subtract, and here again, I'm going to use a lot of parentheses, so I keep everything in order. I'm going to subtract f of x. So again, here I have f of x plus h, and I'm going to subtract f of x. Great. I'm going to divide by h. So first, let's see if we can simplify anything in the numerator. Well, I'm glad I used that extra parentheses because we see I have a subtraction sign and two terms here that I'm subtracting. So that will look like square root of x plus h minus 1 minus square root of x plus 1 all over h. We see that now in the numerator, we get our negative 1 cancels with our positive 1, and we are left with square root of x plus h minus square root of x over h. And now, have we seen this quotient before? Well, this looked a lot like that problem that we did in a couple videos back of just computing the difference quotient for f of x equals square root of x. We see we can even see that in our notes here. So this term and this term is what I'm focusing on. So we know how to simplify and handle the setup here. What did we do? Just recall, we rationalized the numerator by multiplying the numerator and denominator by the conjugate of that numerator. So since we've already seen that before, let's go ahead and just do that quickly together. But feel free to pause the video to get a head start on it on your own, and then you can just breeze through the video to compare your work. All right, so we're going to multiply by square root of x plus h plus root x all over square root of x plus h plus root x. So when we multiply that numerator, we're going to get the radicals cancel out, so we just get x plus h. Now, the beautiful thing about multiplying by the conjugate is that we're able to get the outsides and the insides to cancel. So we just have a 0 for the outsides and insides. And then the last terms, we get square root of x times square root of x, which would just be minus x. In the denominator, we have h times that conjugate. So root x plus h plus root x. All right, not too bad the second time around. So what we see here is that the x and the minus x in the numerator cancel. After doing that, we'll see that the h's in the numerator and denominator cancel as well. But I'll write that out so we just see that step. Here the h cancels with the h in the denominator, and we are left with 1 over root x plus h plus root x. So our final simplified answer is 1 over square root of x plus h plus square root of x. And we see that is the same answer that we got for the previous example. So this just shows us that for the functions square root of x and square root of x minus 1, they have the same simplified difference quotient. So that minus 1 here doesn't change what the simplified difference quotient looks like. And in calculus, when you take some more math after this class, you will investigate what features of a function do affect the simplified difference quotient. All right, thanks for watching, everyone. One more video to go.